Good morning, friends. My name is Ashutosh Garg. I work as a solution provider with Furnace Improvements. Our company is in the business of fire heaters. We provide fire heaters with longest run length, lowest emissions, and highest efficiency. This webinar today is born out of our experience of dealing with customers for more than 40 years. This is our first webinar this year, and I welcome you all. Happy New Year to all our participants. We'll be talking today about fire heater API 560 specifications, missing sections. So the question is, why am I doing this webinar? The answer is that I love fire heaters and I also love API 560. I've spent almost 48 years in the fire heater industry. I still remember in 1980 when one of the burner vendors brought us draft copies of API 560 in India. We were really excited to see a comprehensive document for the first time. I have been a part of API team for almost 25 years. Most of the team members are very bright engineers and with tons of practical experience. Now, our company, Furnace Improvements, is a unique fire heater company. Most of our business is fixing heaters. And what pains me the most is when my clients come to us for help on brand new heaters. One of our clients spent close to $100 million on 3 heaters about 10 years ago. And they had nothing but problems from day one. The heater was retubed twice already in past 10 years. Similarly, we have worked on many crude, coker, and vacuum heaters. And all these heaters were built as per API 560 specifications. So this experience led me to think as to what is missing in API 560 that is causing all these problems. We had done a similar webinar about 2 years ago, and I realized that I did not cover the subject in full details in 1 hour. That is why I have decided to split this webinar in 4 sections and examine API 560 along with you in details with a hope to make it a better standard in future. Learning is a continuous process and we learn from you every time we do these webinars. So please don't hesitate to ask me a question. And please feel free to share your experience with us. We are going to do this webinar through a PowerPoint presentation, which has been prepared by our team in Delhi. We will have the presentation for about 50-55 minutes and then question and answer session for the last 5 minutes. We have been able to improve our webinar based on your feedback. Please send us your suggestions. I will start the session with a brief introduction of myself. I'm a chemical engineer. I passed out of IIT Kanpur in 1974. Since 1976, I've been working on fire heaters and combustion systems. I have worked in KT India, Engineers India, and KTA Corporation in US. Since March 1996, I've been working at Furnace Improvements, fixing heaters for past 26 years. I want to thank our team in New Delhi who have been working very hard for the past 4 weeks for preparing these webinars. I'm the presenter, but most of the effort has been put in by our team. I want to talk to you a little bit about my own experience with fire heaters going back all the way to 1977. And I was working in India and we got a chance to work on 2 crude heaters at Indian Oil Refinery in Gujarat. These were Russian heaters and they were consuming a lot of atomizing steam. The atomizing steam was almost like 1.1 kg per kg of oil, and IOC wanted to reduce the steam because they were looking to put another boiler. So they hired KTI, the company I used to work for, to replace the burners. That job turned out to be very challenging, and it took us almost a year to achieve this objective. At that time, the crude heater run length was typically around 2 years, even less than 2 years. And that was a norm at that time. Now, fast forward 30 years later, and in 2008, we were contacted by Citgo in Lake Charles. And they wanted us to design a crude heater and a vacuum heater with 8 years run length. We accepted the challenge and we designed those heaters. And today I can say with pride that those heaters did achieve 8 years run length. In the US, prior to 1980, we used to have 300 refineries. And today we have only 105 refineries. So we are basically in the survival mode. Only the fittest refineries will survive. And the utilization factor in US is almost close to 92 to 93%. That means you have to run your heaters all the time at full capacity. We are continuing to build oil refineries in the developing industries. And APFI 60 has become a de facto Bible almost everywhere in the world. And that is one more reason to improve APFI 60 so that we can have better heaters everywhere. I want to talk about how I started furnace improvements. And in 1994, I was in Texas City, and there you have 4 refineries next to each other and almost like 100 heaters within a concentrated small area. And I asked my colleague, who was a sales manager, Bob, and I asked him, who is looking after these heaters? And he said, nobody. And I asked him why. He said, fixing heaters is a dirty business. It is a troubleshooting business and you don't get any credit. So most of the heater vendors have been focusing on new heaters. Everybody likes to work on new heaters. As it would happen in 1996, I got an opportunity to take my career in different directions. I decided to take on this challenge and said, oh, let me work on these heaters with the end users and owners directly and fix their heaters. I am extremely indebted to Citgo Corpus Christi, who gave me my first heater study. They gave me my first revamping job of a platformer and even supplying a new heater to them. 90% of our business is fixing heaters. In 2005, when we opened an office in India, we had only 4 people, but now we have grown it to about 35 people. In 2014, we started doing CFD. First, we set up an office in Pune, and last year we merged it into our Noida office for better coordination. There are 2 things I want to talk about that differentiate us from other companies. One is in our name, improvements, and we are always looking for improvements. And you will see anytime you come to us, even for replacing convection section, we will give you an upgraded convection section. We feel that we should try to get you the most buck for your dollars. And second is we have a contrarian approach. We have always been challenging conventional wisdom, and we have been pretty successful. We have 4 patents. They all came out when we challenged the conventional way of doing things. Conventional heaters have series flow with fluid flowing first in convection and radiant section. We challenged and developed a split flow concept of parallel flow in convection and radiation. Similarly, conventional heaters are vertical burners. We challenged it and developed an inclined firing system which reduces the tube metal temperatures and offer better run lengths. Similarly, we studied stack dampers as to what is ailing stack dampers, why they are not able to control the stack draft, and we developed a smart stack damper for effective draft control. With your help and support, we will be completing 27 years in business in March 2023. This is a list of our clients. We have about 35 people in India. We are doing process, mechanical, CFD, structural design. We are a full heater service company. We execute projects on a turnkey basis, including heater erection. Our CFD team has been working exclusively on combustion, heat transfer, and fluid flow. Most of our business has been in US. We have long-term relationship with all our customers. Most of the work which we get is through word of mouth and repeat business. I want to take this opportunity to thank our clients for placing their trust in us. If you're not our customer, we want to make you our long-term client. Give us your worst heater, and we will make it the best heater in the industry. Philips 66 is our largest client for the past 15 years. So let's talk about what we will be talking today. We will start with the evolution of our heaters. Then we will cover the history of APFI 60. Then I want to talk about typical procurement process which is followed in US and elsewhere. And then we will follow on the key parameters that are missing in APFI 60 and can be added. So we will do this exercise for about 50 minutes. And then in the last 10 minutes, we will have a question and answer session. We want the session to be interactive, so please send me as many questions and queries as possible, and we'll try to answer all of them. Most of you know that the refining industry is about 150 years old. It was developed in late 1800s. In the beginning, industry started with the batch process, and we used to have shell stills, basically a vessel where a liquid or crude will be poured, and then it will be heated just like with using coal or coke or wood or any other material. And the vapors will be sent to the condenser and distillation column, and that was how the earlier Burton batch process was able to work. Now these stills were very inefficient. They would always have coke depositing at the bottom because of high heat transfer rate, and they needed to be cleaned manually. So industry would install a series of these shell stills, and some of them will be working and some of them will be in the cleaning mode. And this continued for quite some time before we developed pipe stills. And that was the next stage in the development of fire heaters, that instead of shell, we used pipes. Now using pipe was a big step forward because it allowed a very great surface to volume ratio as compared to the shell. The fluid was also flowing at high velocities. These pipe stills were basically constructed like a pipe bank. You can see in the sketch what is there in the presentation here. This was the heating furnace or the combustion chamber, and this is the convection section. So all these pipe stills did not have any surface in the radiant section, and these tubes which are in the hotter section would keep on getting coked. So they would remove these tubes, and these tubes will get coked, and then they realized that there is still something missing. And later they realized that they need to have heating surface in the radiant section. They need to make a large radiant section and put pipes over there, and the modern pipe steel heater was born after that. This thing. So these are some of the stills which were built by different companies. This is a end wall fired box heater with a downdraft convection section and underground flue gas duct and then a braid mounted stack. This is a box heater with a central bridge wall here, and the burners are again fired from the ends. This is another design with the bridge wall and 2 rows of convection section, and this has a convection section above this. And I want to tell you, some of these heaters are still existing. In US, I have been able to see this heater and these heaters in operation. And so the heaters last anywhere between 50, 60, 70 years. And that's one more reason that we need to be very, very careful about designing fire heaters correctly. This is an A-frame furnace from M.W. Kellogg, which they used. These are the later developments, and you can see these are some of the later developments which came out pretty modern, but basically everything used to have a box construction, horizontal tubes, and from side firing or end wall firing, we graduated to bottom firing. This is almost like a current cabin heater design. And then these are the 2 vertical cylindrical designs. This is a Petrochem's isoflow furnace. Used to have a big cone which would fall down. So these are some of the earlier designs. There are many other designs which have been in existence. And today, we have basically 2 designs. So if you look at the heater industry, the oil companies had all the know-how. Oil companies, because chemical engineering is an empirical science, they would make something and then kind of work out correlations later, to design that or how it was designed actually. So most of the oil companies would have a large engineering and research wings, and they would specify all process and mechanical details and work with the fabricator. That's how these heaters were built. I would say till 1950, 1960s, most of the oil companies up to 1970s were intimately involved in fire heater design. Later, engineering companies like Foster Wheeler, Plumbers, Alcon, Petrochem acquired the technology and came up with their designs. Another major development was a classic paper which will still follow today, is by Lobo and Evans on radiant heat transfer. And the old designs, as I showed you, did not have any heat transfer surface in the radiant sections. And in petroleum refining engineering book, the classic book on refining, they even talk of convective heaters with flue gas recirculation to overcome the coking issue. So that was another development which they did. So most of the heaters would have a basic box surface, horizontal tubes, end wall fired burners. Initially, the industry put 2 rows of tubes in radiant section backed by the refractory. And then they later on realized that the back row was only receiving about 17% of the heat. The front row was receiving the 83% of the heat. So they ended up deleting the back row, and in 1950s, we started using single row of tubes. And today we have double fired tubes. That means single row of tubes fired from both sides. We call them double fired heaters. Vertical tubes is a recent development. When I say recent, I'm talking of another 50, 60 years now. and vertical cylindrical heaters have become almost like a de facto design configuration, and bottom firing has become almost universal actually. So let's come back to API 560, and before API 560 there were no fired heater specifications. Every company used to have their own proprietary specifications which they would use for designing fired heaters. There was nothing available to independents and all other refineries all over the world. So API is American Petroleum Institute. It constitutes of all the oil companies in US. It has a subcommittee on heat transfer, which looks after all heat transferring equipment, exchangers, fired heaters. I believe API started working on this heater in late 1970s. And they have been working on it for almost 50 years now. They meet twice a year for about 3 days for technical discussions. The task force includes end users, engineering companies, and vendors. The good thing is that these meetings are open to everyone and technical matters are discussed. As I said, I've been a member for a long time. The committee's goal is strengthening the specifications of fired heaters. It takes 5 to 7 years to revise these standards. Before API 560, the API committee developed API 530, which is a standard for calculating heater tube thicknesses. And in the last 40 years, we have more APIs. We have an API for burners, API 535, API 536 for SCRs. And all these standards represent a very good knowledge. So when API 560 was issued, it was a very important event. And the objective of the specification is to provide a purchase specification to facilitate the procurement and manufacture of fired heaters. The primary purpose of API standards is to establish minimum mechanical requirements. It covers the minimum requirements for design, material, fabrication, inspection, testing, how to shape erection of fired heaters for general refinery services. So all in all, API is an excellent document, API 560 in particular, very well respected in the industry. The first issue came out in 1986. The second edition came out in 1992, and since then we have got 3 more editions issued in 1996, 1999, 2006, and 2016. It is undergoing revision, and I believe a new document will be issued in the next couple of years. API has also started practice of issuing addendums now. And for most non-critical heaters, you can buy a good heater with just the process data sheet and ask vendor to follow API 560. What we find is that there are still a lot of improvements that can be made to fired heater during design stage. And it's always cheaper to fix things on paper than in the field. We can get better and reliable heaters with better heater specifications. So as I said, very, very good, impressive document followed all over the world. Initial document was 62 pages. The 2016 edition is much more comprehensive and is 400 pages. Let's talk a little bit about how fired heaters are procured or how they are bought. in US and everywhere else. And most end users, they hire a technology company to prepare a feed package. These feed packages have process data sheets for fired heaters that are passed on to the EPC. EPC then goes and wants to come up with a FEL0 or a FEL estimate for the project. What they do is they contact a couple of fired heater vendors and get budgetary proposals. They may have a couple of rounds of discussion to finalize the budgetary bids. EPC then firms up the project cost estimate, the project gets approved, and then they start, based on their previous discussions, they firm up the heater data sheets and go out for bids with all the technical specifications. The vendor firms up all the data and submits a proposal. Now, heater business has become very, very competitive. And there are a lot of actors who are available now for doing fire heaters. So heater vendors submit the most economical bid because the way business has been looked at now, that EPCs look at only the lowest L1, L2, and at the most maybe L3 bids. So the race is to get down into L1 or L2, So that is one reason why the vendors keep on cutting corners in heater design. Also, the EPCs, they include BMS, fuel gas trains, and the heater vendors are really not capable of doing these things. So they end up spending tons of time focusing on BMS, fuel gaskets, instrumentation, piping. And as a result, the heater design takes a backseat. Anyway, finally, they make a technical comparison, they issue TQs, and they select the lowest bid in consultation with the client. And they issue a heater, and the heater vendor supplies the heater. EPC checks all data sheets, documents, fabrication, drawings to ensure compliance. What is happening is that in this process, the most critical issues, they take a backseat. And there are a couple of reasons. One is the experienced heater engineers are in short supply. And with the advent of powerful computer programs, their need is felt even less. So things like reliability never figures in the heater evaluation. Nobody is talking of with how this heater is going to work, how reliable will it be, what will be the run length, what will be the coking tendency, all those type of things, they take a backseat. And I have the benefit of working on all the sites. I've been a heater vendor for 10 years. I've worked in EPCs for 8 years. I've been a heater consultant for 25 years. And it's a very tricky process because when EPCs send you inquiries, they run in thousands of pages. And within 3 weeks or 4 weeks, you're required to submit your bid. So the design team develops the most economical design, meeting the process data sheet and API 560. And basically, the pressure to come L1 is so high that sometimes you even violate some of the requirements at the first go. So there are 3 entities in fired heater procurement process: clients, licensors, EPC, and heater vendor. And who is the victim in the whole process? It is the client that ends up with the heater that was supposed to be solving all the problems they had with the old heater. They think all limitations will be gone, but when they operate the heater, they start realizing that two metal temperatures are going up. The heater is coking up, shutting down every 2 to 3 years. They have to pay. Every time you shut down the heater, you have to spend millions of dollars. One extra shutdown will wipe out all your savings. And our recommendation is to pay a little more upfront, get a reliable heater, And we did a study, we found that the cost difference between a cheap heater and reliable heater is only 15 to 20%. So what we are seeing is there is a major disconnect between the end user and heater vendor. And that is what is causing most of the problems. Let's go into details and talk about the fire heater. Fire heaters are very important component in the refineries. In fact, if you want to describe the refinery in two major equipments, it will be heaters and columns. Fire heaters are major energy consumers. 0.44 million BTU per barrel of oil is that much. How much energy do they consume? Are used for high temperatures, heating of fluids all the way up to 1000 degrees F. This is the only equipment where you are exposed directly to flames. Fire heaters are major source of greenhouse gases, and my thinking is you will see big changes in the next 20-25 years. Fire heaters are major source of NOx emissions. And coking of tubes is the most common problem. Run length is another issue. And what we have to think is that most of the heaters are there for 50 years, 60 years, 70 years. So when you build them, you need to take ample precautions because it is not easy to modify or revamp fire heaters. So issues important to most owners are efficiency. Issues important are emissions. They have to comply to EPA, state local pollution authorities. Run length, most important issue. Overfiring, safety, and high tube metal temperatures. So you can see some of the heater pictures, over here. So let us talk about what is missing in API 560. And the first thing which came to my mind is efficiency. There is no guidance on heater efficiency. And vendors will design heaters to the lowest efficiency because they want to keep the cost low. That's the only way they will get business. And now we know that if you have lower efficiency, you will have more pollution. You will have more greenhouse gas emissions, more thermal pollution. So this is just my recommendation that API 560 should specify a minimum thermal efficiency of 90% or even higher for heaters, maybe let's say more than 60-70 million BTUs. That will be one way that we can contribute to cleaning up of this world. One way we can minimize the CO2 emissions. In all honesty, I'm still thinking hydrogen firing, even though everybody is talking of hydrogen firing. My thinking is hydrogen firing is at least 20-25 years away from today, so why not do what we can do today? Fuel prices keep on going up, and let us not worry about the fuel prices and focus more on the pollution side and improve the efficiency to the max. That will be, and API 560 can do it. It's a very powerful document specifying the minimum thermal efficiency or approach to the inlet fluid temperature of 50 degrees or 25 degrees will really, really help. We are looking at some heaters, large heaters, almost like 200 million BTUs or 250 million BTUs in Texas with a temperature of almost flue gas temperature of almost like 800 degrees F. So you can see how much energy saving potential is there in these heaters even today. And unless the API 560 tells people that and guides people, things will not happen. So I feel we should do it. In US, especially where we have almost like 2,000 heaters, 100 refineries, 20 heaters per refinery. Now 90% of the heaters in US are natural draft. And when your 90% heaters are natural draft, your efficiency is only about 70 to 85% at the most. And that offers a savings potential of 10 to 15%. So you can cut down your emissions by 15% just by improving efficiency. And there is a payback because every time you cut down the fuel consumption, you get fuel savings, and that they pay back also. Plus you emit lower amounts of CO2, So I think the API 560 should start addressing this issue. Next is the emissions. And API 560 is also silent on NOx emissions. The local rules keep on changing, and what we are seeing is that in US today we can buy burners maybe with 30 ppm or 50 ppm NOx, and if we put SCR we can go down even to 10 ppm. SCR is selective catalytic reduction system. We have an office in India and we are doing some business in India, and what I understand is there are 200 heaters which are being built, and all of them are still using the staged fuel gas technology for NOx reduction. And that is because their local laws say we want only 75 or 100 ppm NOx. Now, the cost of the burner is the same, whether you go for an ultra low NOx burners or you go for staged fuel burners. And I'm sure all these burners which are being put today will need to be replaced in next 10 or 15 years when they will be asked to go down to 30 ppm or 50 ppm. And if the technology is available, if API 560 says just one sentence, use lowest NOx emission burners, most of the people will pay attention, most of the buyers will pay attention, most of the vendors will be forced to offer lowest NOx burners, and we will reduce the NOx emissions without spending anything extra. So this is more applicable in developing world where they are still not that stringent on NOx, but the technology is already grown and it's already available. Why not make use of it? Fire heater duty, most important parameter that defines the capacity of fire heaters to transfer heat. As we have been talking of, that fire heaters are built for 50 to 70 years. What has happened in the past 40 years is that we have upgraded our preheat trains to reduce the firing duty. That's a very good approach. However, in practice, most of these heat exchangers fail to perform due to fouling and other issues. And I see inlet temperature starts taking a beating, leading to increase in heater duty. It is a very common occurrence in US. Very seldom will we see a crude or vacuum heater operating at inlet temperature close to the design. The process engineer, the heater engineer, the exchanger engineer should be made aware of the situation and should have enough margin so that we can avoid such overfiring. It will really help if we can estimate the heater duty correctly. It will really, I mean, cost of adding 10% extra capacity is only 2 to 3% as compared to in the initial. Another issue which I have already talked about is run length. And run length does not figure in API 560 also. Whereas API 560 is catering to the refining industry, and in refining industry, we are mostly heating crudes or hydrocarbons, heavy hydrocarbons. And run length is the most important issue in the minds of operating personnel. And we don't talk about it, we don't even evaluate what is the coking potential, what is the run length. So as a result, you can buy a heater which may have a much higher coking potential. And you may have to shut down it every 2 years without realizing it. So I feel that API 560 should talk about run lengths, should maybe specify some sort of minimum run length, could be 3 years, could be 5 years for different services based on the experience, so that vendors get a guidance and also the clients know what they can expect, and how they can increase the run length. I feel it's a very important parameter, especially because we keep on fixing heaters day in, day out, and we see run length is a big problem. API 560 has 2 sections, normative, which needs to be followed, and then there are annexures, which are meant for providing information. And I think maybe in the first go, we can add more information in the annexures, and then maybe slowly we can transfer it to the normative. There are equipment data sheets, very comprehensive equipment data sheets. There is a purchaser checklist. There is a shop assembly checklist. There are stress curves for designing of tube supports, centrifugal fans, air feeding system, how to measure efficiency, stack design, measurement of noise from fire heaters, refractory compliance. So API 560 is a very good document actually. I mean, it covers everything. But fire heaters also is an equally complicated subject, and it needs more treatment, It needs more handling, and that is what we want to talk about. So somehow the process design considerations did not get enough attention in API 560. And there is only one page in the whole 400 pages documents which talks about process design or design specifications. And one of the main issues which it states, it talks about heaters shall be designed for uniform heat transfer. But it does not talk about how. How will you ensure that we are having uniform heat transfer? That's a big gap. I've been a vendor, nobody talks about, are we making sure that there is going to be uniform heat transfer? And what mechanism are we using for verifying uniform heat transfer? Also, I feel that there has been an attempt in diluting the specifications, and that could be back in 1980, API 560 was dominated by end users. 75% of the people were from operating companies. Today, 75% of the people are vendors in API 560. So because of the change, there has been some dilution of specifications. And you can see earlier in APFI 60, it used to say multi-pass heaters shall be designed for hydraulic and thermal symmetry. And I don't know why thermal symmetry got deleted. It was diluted. And pass imbalance is a common problem in fired heaters, especially in cabin heaters. So uniform heat transfer. Actually, if we can achieve uniform heat transfer in fired heaters, we won't have a job anymore. Most of the problems relate to non-uniform heat transfer. And to me, uniform heat transfer in radiant section is like a mirage. We keep on chasing endlessly in most heaters, but never achieve it. If we can have uniform heat transfer in radiant section, we can eliminate hot spots, we can eliminate high tube metal temperatures, we can eliminate coking or reduce coking. It will lead to extended run length of fired heaters. And I talked to you about the work we did for Citco, where we gave 8 years run length. So recently, Citco wanted to replace 2 more crude heaters in their Lake Charles refinery, and they came to us again for process design of fired heaters. If you want to have trouble-free fired heaters, you can hire us, and we can give you the perfect design that will keep on running for 8 years, 10 years without any issues. So uniform heat transfer, no hot spots, no high tube metal temperature, no coking, extended run length. It's almost like. I want to give you some practical examples of what we have experienced in the past 25 years. This is a heater, vertical cylindrical heater with 100 million BTUs in crude service, 12 burners on the floor. And you can see radiant tube metal temperature profile. We are seeing all the way up to 1100, 1200 degrees F. And that indicates that the heat transfer is not uniform. The good thing is we now have CFD modeling capabilities available, and we can see how the heater is behaving in practice. This is another heater, and you can see we talk of uniform flux, but in the top 1/3 we experience 7,000 flux, middle we experience 15,000 flux, and average at the bottom was 22,000 flux. And so the average overall was 13,000, but you can see how it has been differing. And this is how the flux profile is. Like here, we get flux which is almost close to 40,000, 37,000. So uniform heat transfer, we'll talk more about it in the future sessions, but it's a big issue. This is a cabin heater, and it was a crude heater cabin, and this was receiving only 26%, and this was, this was receiving more heat. This was receiving very high heat. This was average, and this was lowest. So the top arch was heavily, like 41% of the heat was being received over here, and this section had high tube metal temperatures and hot tubes. So cabin heaters have issue of thermal symmetry, how to achieve it. This is a coker heater, double-fired coker heater, and you can see how the flames are so close to the tube. So how will you have uniform heat transfer in a coker heater? Coker heater is a very important heater in the refinery. It's the most money-making heater, and you want it to run for a long time before you do the decoking or pigging. So I think the APFI 60 can definitely be strengthened to address all these issues and get better heaters. So these are some localized overheating examples. Whenever you have hot flue gas close to the tubes, it will create hot spots. So kind of closing now, basically designers assume uniform heat transfer in fired heaters. CFD modeling shows other way, that the heaters do not have uniform heat transfer, and flame impingement can lead to tube metal temperatures, coking of tubes, and shutdown. And this is a picture of our patented inclined firing technology, and we have seen that by using this inclined firing technology, we are able to get much better heat distribution and much lower tube metal temperatures. I mean, it still does not go to uniform, but in existing heaters, if you are having high temperatures or you are having coking issues, putting this inclined firing will help you substantially, actually. We have done it in about 15 heaters now, and by putting burners at an angle, we keep the hot area in the center and we get much uniform heat transfer. Another issue in API 560 is on the combustion side. What we do is, when we design a fire heater, we design the combustion system. There is a process side. That process side is designed for 100 million BTU. But the firing side is designed for 120 million BTU. And that mismatch creates a problem for most of the users, because users think that the heater is designed to run at 120 million BTUs. So I feel that there is no need to provide this extra margin. And if you want to provide extra margin, you provide extra margin on the process side also, so that the both sides are balanced. And fortunately, we don't have oil firing in most of the places. Oil firing may be needing a little bit of standby capacity because oil burners get clogged up very fast. But with gas firing, I feel that you should be able to balance both the fuel gas side and the process side. We don't see any issues there. In the future sessions, we will be talking a lot more about a number of critical design parameters, fluid pressure drop, fluid mass velocity, average heat transfer rate, coil size, number of burners, burners configuration, volumetric heat release, height to diameter ratios. We have tons of information, because we feel that if we can educate our clients, they will take better decisions, and it will help everybody. An informed client, in our opinion, is a better client than a client who gives everything to you. So if you want to get best heaters for your money, higher furnace improvements, I have to do some marketing. We can work with you to develop the best design for your unit, for a heater, looking into the plot space budget. We give you the data sheet, coil and insulation summary, preliminary GA designs. You give it to the EPC. EPC asks all the vendors to submit the bid for one design, and you pick the lowest vendor. So you end up a winner. You have the best design and lowest price. So if you have a heater, you can use our services, and we can provide you the best design possible, guaranteed. Well, thank you all for listening to me. It's been always a pleasure to talk to all of you through webinar medium. Let me see if you have any questions. Let me see on the. Okay, I don't see any questions. If any one of you has any questions, please type your questions and show, Okay, if there are no questions, I would like to stop the seminar here. I mean, our webinar here. Please, you can send me an email, and if you have more questions. Oh, yes. Any inclined burners in India? Yes, we have burners working in HPCL Mumbai. We provided them in 6 VC heaters. They have been working very, very nicely. We are providing inclined burners in IOCL Panipat. I believe we are supplying a heater through BHEL. So what we have done is, any heater we supply now, it comes with inclined burners, especially the VC heaters. The VC heaters, when we see, we don't have to spend anything extra. We just have to modify the floor, so you get much better performance from these inclined burners, and we are supplying it at a de facto. I have a question from Brent. Do you work on ethylene furnaces? Yes, I work on ethylene furnaces on everything except the coil. I don't touch the coil, especially because it's a proprietary design, but we can work on burners, we can work on convection sections, ID fans, efficiency, everything, you know, except the coil. You can do the CFD modeling of your cracking furnace, but we don't want to get into the reaction kinetics and those other issues. So if you have a high tube metal temperature issue, if you have any issues, we can try to help you. Any other questions you have, please, in the last couple of minutes. Combined stack in natural draft, that's a I don't like it. If you ask my opinion, I really don't like it, but there are certain cases, especially with this new regulations of putting 60-meter stack, the economical alternative is to combine the stacks. It's not a good design for operations because the draft control becomes a nightmare. I mean, you need to provide a proper draft control scheme, but most of the time what we have seen is, if you have a common stack and if you change conditions in one side, the other side automatically gets changed. So if possible, keep separate stacks. Negative aspects of keeping draft too negative. Like -15, that's a very high draft. I don't recommend it. You will have more air. I mean, nothing will happen. The heater will not fall down, Deepak. I mean, we have seen heaters running at 0.2, 0.3 inch, which is like -8. But I don't see any reason of keeping it -15 actually. I mean, unless your ID fan is not working or controlling, there is no reason to keep -15. Do you troubleshoot reformer heaters? Yes, we do troubleshoot. Actually, I started my career in an ammonia plant where we had a topso reformer. I worked there for 2 years. Then I worked at KTI. KTI is a hydrogen plant company. So I had worked on several reformers. But again, we don't get into the catalyst side, But everything else we can work on the convection section. We can come on the radiant section. Yeah. Somebody is asking me the formula for calculating efficiency. I think APFI 60 has a very elaborate annexure for calculating thermal efficiency. Please look into that. Is there any application in which an indirect fired furnace will always perform better as compared to direct fired furnace? Well, I mean, if you can, indirect fired furnace is nothing but a heat exchanger combined with a hot oil heater. That's what it will be actually. That's what, you know. So it will always, heat exchanger will always perform better than a fired heater. But how do you heat that oil? Fired heaters are used for exclusively for high temperature heat transfer. So if you can use a heat exchanger, which is indirect exchanger, indirect furnace, so you can use, it will always be better, you know. All right, guys, thank you very much. I really appreciate all your questions. You can keep on sending me even later, and hopefully guidelines when to use SR and LR. I think I don't have enough time, but it will be, when you use LR, they are not economical. It increases the size of the furnace, the radiant section, although it does lower the maximum radiant flux, but industry uses SR as a standard. So keep on sending me your questions for the next webinar. I mean, I would like to, you know, maybe someday I will write a book, you know, let's see. Thank you all very much. Yeah, thank you. Bye.